Okie doke. All right, so this is just a practice recording, which is gonna be like 5 minutes. I'm just gonna try to go over the Bayesian slides uh, and get a short presentation. So Bayesian reasoning is a very important key aspect of Data 101. It's an interesting story behind it. Thomas Bayes has invented it in 18th century, and this is his only paper which he ever published. It was published after his death, but nevertheless he was admitted to Royal Academy of Science without any papers or any books, and he just had this one paper which is absolutely fundamental to machine learning, data science, etc. So Bayesian reasoning is fundamental in data science, in common sense probability, because it helps irrational pessimists. Bayesian theorem tells you it's not as bad as you think it is, and it's better than anxiety mad. And I can explain to you how. But objective of teaching Bayesian reasoning is to basically learn fundamental concepts of it. So it's a concept of belief and observation. And then following the so-called odds version of Bayesian theorem, prior odds, true positive, false positive, likelihood ratio, and finally posterior odds. I'm going to skip this history here. Let me just get to this point here. So we start with prior beliefs. These beliefs before we even do any observations. Then we have observations, and we have finally posterior beliefs, which we calculate from the prior beliefs. Observation is something we know, and belief is something we do not know. So that's how you assign different parts of your task to observation or belief. And it's absolutely fundamental, because if you assign it in the wrong way, then your entire calculation is going to be wrong. So remember, observation is something we know, belief something we do not know. So let's look at an example. Belief is I have COVID, observation is tested positive. So you tested positive, how likely it is that I have COVID? Now that, of course, is a good example of a situation where you can panic, right? Because you think you have COVID, but not so fast, right? Not so fast, because let's just calculate the odds, right? So the odds are defined as follows here. This is a synonym of probability, but defined a little bit differently from a probability, because it's p divided by 1 minus p. So probability 0.5 translates into odds 1 to 1. Probability 0.25 translates to odds 1 to 3, etc. So we start solving this problem about COVID from estimating prior odds of having COVID. So let's assume you have some symptoms. It's not like you're completely healthy and we're gonna just ask, do you have COVID? But let's assume you have some symptoms which worry you. So now the question is, what are the odds you have COVID? 1 to 10, 1 to 100, or 1 to 10,000, 1 to 1,000. So let's assume it's 1 to 100, right? Now we ask about the test, how good the test is. There are two parameters of the test which are very important, true positive and false positive. True positive is, if I have COVID, how likely the test will say yes. In other words, how likely this is going to detect the COVID which I have. False positive is, if I do not have COVID, how likely the test will scare me and say yes. In other words, it will give me false positive. It will lie, essentially, that I have COVID, which in fact I don't. Right? So these are the two values. So let's go with odds of let's take the odds of 1 to 100. Let's assume that the COVID test is 99% true positive, and let's assume it's 1% false positive. In other words, 1 out of 100 tests is gonna lie to me that I don't have COVID, but it's gonna say I have COVID. So now let's see, with a test like this, which seems like a very strong test, 99% true positive, only 1% false positive, what is the real posterior odds that I have COVID? So we go over this and calculate it, and Bayesian theorem odds version will tell you basically you calculate the true positive to false positive ratio, which is 99, and you use the following formulation. Posterior odds equals to likelihood ratio times prior odds. And now, to our surprise, we know what prior odds are, we know what likelihood ratio is, 99, prior odds are 1 to 100. So what are going to be the posterior odds? Well, these are the probabilistic formulations, which we already mentioned, but more notation, etc. But the most important punchline here is if the prior odds are 1, actually 1 out of 99, because we said probability was 1 out of 100, 1 out of 99. So what are the posterior odds? We multiply by 99. So we get 1, which means the posterior odds are 1 to 1. In other words, 50-50. That's so much better, right? So much better than initial panicky result. I mean, basically, you don't know anything. You with a test like this, you better have lower false positives or higher true positives. Otherwise, it's gonna be okay. Maybe you have it, maybe you don't.